Boom! Yes folks, Hume here again. So in this video, we're going to deal with a topic that I consider to be a very straightforward topic. And you will see why I say that a little later in the video. Right? This topic is the topic of using the quadratic formula to solve a quadratic equation. Alright? Now why would I say that this topic is straightforward? Why would I say that this is something that no student anywhere should ever get wrong in an exam? The reason, first of all, is that the formula, for all intents and purposes, practically speaking, is not something that you have to memorize. What do I mean by that? What I mean to say is that most examining bodies all over the world provide the quadratic formula as part of the formula sheet. Alright, so you don't have to memorize the whole thing. Now, of course, if in the course of your preparation you were doing the right thing, the correct thing, and doing questions and doing questions and doing questions and practicing as you go along, you do enough questions and eventually you'll realize one day, but wait, I remember in the formula is sticking. And again, all that is part of the value of doing plenty of questions. You wouldn't have to worry about memorizing a formula or cramming a formula. It will just be there because you would have called upon it so many times that it will just be there. And of course, in the context of an exam, you get a question on the quadratic formula and you can just run through it without having to refer to the formula sheet. But if there is some instance where you forget the formula, right? Let me say it doesn't bother to memorize it. Let me say for some reason or the other you blank out on the day of the exam. You just turn to the front and you look for your formula sheet. You get your quadratic formula and you solve the equation. So what I'm going to do is work out a past paper question from the CSEC examination. This would have been the January 2013, number 9. In the relations and functions, I'm going to work this out, and this topic is so straightforward that I don't even believe I need to work out anymore. The only thing I may need to work out, and I say may, I say not very guardedly, is a situation where we have a negative coefficient of x squared. If somebody somewhere asks for me to do a video on that, I might probably do it. But if that doesn't happen, I will leave this one up and trust that you could take the explanation from this into any question where they ask you to work out the quadratic, using it to work out a quadratic, to solve a quadratic equation, using the quadratic formula. Right, so what is the quadratic formula? Right, remembering of course that if we have a general expression, ax squared plus bx plus c is equal to 0, the quadratic formula tells us that x is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. That is the quadratic formula. You don't have to memorize this, but you wouldn't have to think about actually memorizing it because it will happen on its own, almost naturally it will happen. Organically, if you want to use that word. If you do enough questions of practice. So again, I want to take the opportunity to encourage people to practice. So the question as given is, they ask us to solve the equation 3x squared minus 5x plus 1 is equal to 0. And listen to how the question reads. This is number 9B, part 3, January 2013, CSEC Mathematics. Solve the equation 3x squared minus 5x plus 1 equals 0, expressing your answer correct to 2 decimal places. And I want to spend a couple of minutes talking about that last phrase there. Because generally speaking, in an exam situation, in an exam context, in a lot of the questions, they tend to give you hints, they tend to give you clues as to what they expect you to do, right? And just as is the case in normal life, where sometimes in our daily interactions with people, we don't always say things blatantly. We don't always read and spell every last detail. We might give a little hint, we might give a little clue, we might drop a little, we might just say something and leave the listener to figure out the rest or to figure out what it is we mean. The same thing happens in mathematics exams. Alright? So anytime you have a quadratic equation to solve and they say something like giving your answer correct to 2 decimal places, or they might say giving your answer correct to 2 significant figures, or anything that sounds remotely like that, that is as solid a clue as you could possibly want that they want you to go immediately to the quadratic formula. So in other words, you don't get a question like this in an exam where they explicitly tell you to express your answer correct to 2 decimal places and try to factorize. You don't do that. That's wasting time. Right? First of all, you have absolutely nothing to prove to anybody. Right? Leave your ego at the door when you go in to write the exam. It's marks we're looking to get in now. You can pick it up on your way back out. Right? Secondly, even if you try to prove anything, you'll run up against a brick wall. Because if they go to the extra length of telling you to express the answer to 2 decimal places, then you're 999 times out of 1,000. What that means is that the expression is not factorizable, and you will be well advised to leave factorization alone. So anytime you see a hint or a clue like that, don't even think about factorization. Just go straight to your quadratic formula. Alright? So in this case, the very first thing we do is to lay out the constants of this equation in accordance with the general quadratic equation there. So we know, for example, here that A is equal to 3, B is equal to -5, and C is equal to +1. And given that information, all that we need to do is simply substitute these values into this equation here, and boom. Now, of course, the complexity here is that we have some minus signs to deal with in the general formula. Boom, minus b here. Boom, plus or minus here. Boom, b squared minus 4ac here. And chances are that in an exam setting there will be a minus sign somewhere inside here. It is very unusual. It is not usually the case in an exam that they will give you a quadratic expression with just positive, everything being positive. Right? You'll usually have at least one negative quantity to deal with. So you have to get used to it. Right? The negative sign is part of mathematical life. There is only so much time you can run away from it for. Eventually you'll meet it in a context where you simply have to reckon with it. So this is one of those cases. So next step here now is to simply substitute this back into that fella across there. So watch it now. We say in that x and we just substitute it. Now usually for the purposes of an exam, what I would do, and again I'm saying this not pressuring anybody to do what I would do. What I would do is write out the whole formula just to have it right there before me, so that as I substitute, I could see where the value is going. So for the sake of consistency, I will do that. Alright, so what I would normally do is say x is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. So having written out what is a and what is b and what is c, the next step is to write out the general solution where these general values come into play with the specific values up here in this line, and then the next step would be to simply substitute. So if x is equal to this and b is equal to that and a is equal to that and c is equal to that, then the next step is simply to substitute. So watch it. Minus 5. First opportunity for error here. What a lot of people will do here is just put -5 because of just sheer laziness. But if b is -5, then this minus sign has nothing to do with that minus sign at this point. where we just simply substituting. Yes, we will multiply them later, but we're not there as yet. Plus or minus the square root of b squared. B is minus 5 still. So minus 5 in brackets. Notice I've been very careful with the bracketization of the negative quantities. Right? Minus 5 squared minus 4. Your a is 3 and your c is 1 all over 2 by your a is 3. Right? Right. So in other words, we have not done any arithmetic yet, and this is one of the reasons why I usually tend to be slightly exasperated when I'm doing this question with my own students and they get it wrong. This is not a question they get wrong. I'm not saying that, I'm not being arrogant or anything like that in saying that. I'm saying that to signal to any student that if you set yourself up to believe from the outset that the quadratic formula is not something that I could get wrong, and you start off with that, it means that as you practice, that is the space where you're making mistakes. You give yourself room to make mistakes when you practice, which means that you're going to practice enough questions so that you're going to make enough mistakes so that eventually you'll reach a point where you could do it flawlessly. Because this is a topic that you could do flawlessly. Alright? So as I said, not a single drop of arithmetic has been done yet. We haven't performed any operations. All we would have done is simply substitute the values that we got from this expression, which we had written out here. We just substitute. And if you had performed your substitutions correctly here, taking extreme care with your brackets, then it will make your life a lot easier going forward. Good? So I'm going to rub off this guy in the corner here and continue working on this side of the board. So, yeah, we need the space here now. Right? I'll have it on video, so I could rewind and thing. Right? So your next step is to continue. Alright? Divide the board there. And we come down here. And yeah, we'll leave the ink in blue. That's just right. So minus multiplied by minus is plus 5. Right? So that is equal to 5 plus or minus square root sign. Minus 5 in brackets, all to be squared is plus 25. 4 by 3 is 12. 12 by 1 is still 12. Right? 25 minus 12 all over 2 by 3 is 6. So it starts off looking all complicated and stuff, but as we substitute and as we perform the operations, we see it start to get simpler. So this here will be the very first time that we would have performed any kind of arithmetic operation at all. So that would be now 5 plus or minus the square root of 25 minus 12 is 13 all over 6. Alright, so at this point I'm going to invoke my calculator and see what answers we get. So the square root of 13 is what? The square root. Square root of 13 is equal to 3.6055. So what I generally advise is that if they specifically ask for the answer to 2 decimal places, you don't want to round off to 1 decimal place. That is absolute and total madness. Alright? So that will be 5 plus or minus the square root of 13, which is 3.6055. Let me say 3.61 all over 6. Now, here is where sometimes people tend to get lost. But generally what I have observed is that if people get to this point, then the next point is usually just a mere formality. So the plus or minus means that you have 2 values, which you will always get if you solve a quadratic equation. Let me say it again. If you solve a quadratic equation, you will always have 2 answers. Sometimes the 2 answers might be identical, but that is a separate topic for a separate occasion where we'll discuss that. Right? you might get a quadratic expression where x is equal to 8 and the next x is equal to 8. So both values of x end up being the same value. Good? But generally speaking, the values are distinct. But whether the values are distinct or not, they are regarded and considered as two values. Good? So, and I'm saying two values when you're solving a quadratic equation. So this 5 plus or minus 3.61 over 6 is the same thing as 5 minus 3.61 over 6 or 5 plus 3.61 over 6. So in other words, we simplify the working by keeping the plus and the minus sign together up here, but at the very last step we could open it out and actually see the two solutions as distinct entities. So from here now we're gonna go back here and erase the side of the board, and that is where we will change the color of the ink. So coming up here now, we have, again, remembering of course that you always have the ability to rewind and to pause and whatever, right? So 5 minus 3.61 is what? 1.39. So this, so your x would therefore be 1.39 over 6, or 5 plus 3.61 is 8.61. 8.61 over 6, which would be, let me check it out. 1.39 divided by 6 is equal to, boom, 0. They asked for two decimal places, right? 0.23 or 8.61 divided by 6 is equal to, what's it again? Boom, 1.44. So in other words, x is equal to 0.23 and x cubed is equal to 1.44. So you get two distinct values of x as per the dictates of solving a quadratic equation, where you will get two answers. Alright? So I'm going to only work one example of this for the purposes of the video, with the hope and the expectation and the exhortation that if you are a student, most especially if this topic was given you any kind of problems at all, that you do what I would encourage you to do anytime in maths: find questions and practice, find questions and practice, find questions and practice. That is the only way you're going to get this thing right. It's like learning a musical instrument or learning to drive. It doesn't matter how much books you read, it doesn't matter how much videos you watch, it doesn't matter how much lectures you attend or how much time you spend talking to somebody who knows the thing. Until and unless you get in there and start working on it yourself, you will not start to make that progression in terms of learning how to do it. The only way to learn how to do it is to do it, right? And as you do it, you will make mistakes along the way. Yes, mistakes are part of the process. Anybody who told you that they never made mistakes learning maths is a liar. A liar. And I can tell you that, right? Everybody makes mistakes. Mistakes are part of the process. But the whole point of the process is to develop your proficiency, so that on the day of the exam itself, when you'll have to perform under pressure, the pressure itself could foster errors. So you want to get to the point where you could perform smoothly and efficiently even when you're under pressure. And when you could do that, then you know you could do it, then you know you have it. And of course, as I always tell my students, you apply the mentality and the work ethic and the flow of results to anything else in your life. It's a process, it's a mathematical process, and I want to encourage people to do that. So that's it. Solution of quadratic equations using the quadratic formula. So as always, take care, be good, and look out for the next video.